Hi guys, today we are going to do experiment number 4, series parallel circuit. The components required are resistors 1 kilo ohm, 2.2 kilo ohm, 3.3 kilo ohm, power supply unit, DC power supply, a digital multimeter and an analog multimeter VOM. I have the components here, the resistors, the connecting wires, jumper and the breadboard. First we are going to connect the series circuit like this with the DC power supply set to 10 volts. The VOM is going to serve as an ammeter, 1 kilo ohm resistance in series with 2.2 kilo ohm in series with 3.3 kilo ohms. All of them should be connected one next to the other and back to the power supply. I am going to bend the resistor like this. I have fixed these resistors on the breadboard individually. I am going to measure them and note the values in here. Now I am measuring the resistance across the first resistor. Similarly, I am going to measure the second resistance and the third resistance. Note the value from the DMM, set in resistance mode. I measured the resistances and have noted it here. I have set the supply voltage to 9.9. I have to set it to 10 volts. Just adjust from here, set it to 10 volts. This is the VOM set in ammeter mode. I have set in 10 milliampere range, and see the terminals, the positive and the negative terminals are connected here, and this knob is set in positive DC. Now I am going to connect the positive of the power supply to positive of the ammeter, negative of the ammeter to the resistances combination, and the other end of the resistance combination back to the negative of the supply. From the positive of the power supply, I have connected it to the positive of the ammeter, and negative of the ammeter is here. It's going to the first end of the resistances combination. The last end of the resistances combination goes back to the negative of the supply here. Now I'm going to set this as voltmeter DC. It is reading millivolts DC. Right now the DMM is set in voltmeter position. See if the probes are connected here and here. This is positive of my voltmeter, negative of my voltmeter is here. Now the ammeter reads a current. For the ammeter, I have set it in 10 milliamperes range, so I have to read from these markings. I have to read from the third markings. The scale is the one that is facing down, and if this is 10, this is 8, 6, 4, 2, 0. If this is 0, this is 1. The primary division is 1, and each of the secondary divisions you should count, and this is current 1.2, 1.4, around 1.6 milliamperes. It's in this third secondary division. I have noted the reading here. Now I am measuring the voltage across R1, and then across R2, then across R3. I am measuring the voltage across R1, R2, and then R2, R3. This is VB and this is VAC. Now we have to measure the total resistance in the circuit and note in this place. When I am measuring the total resistance, I should take out from the power supply. I have the terminals just free like this, and then measure the total resistance from points A to D. Now we are going to hook up the same resistors 1 kilo ohm, 2.2 kilo ohm and 3.3 kilo ohm in parallel like this with ammeter connected for measuring the total current, and the power supply voltage is again 10 volts. Positive of the power supply going to positive of the ammeter, negative of the ammeter going to the resistances combination, and the other end of the resistances combination goes back to the power supply negative. I have connected them in parallel. See that they are between the same two lines on the breadboard. I'm going to measure the resistance across the combination. Between any two ends I can measure. It's going to measure the same and note it in the table. See the positive of the supply going to positive of the ammeter and negative of the ammeter going to the resistances combination, and the other end of the resistances combination goes back to the supply negative. Now we can read the current. I have set it in 100 milliampere range. Here I have set it in 100 milliampere range. Therefore I don't see 100 here. I would consider 10 as 100, multiplying each of the values by 10. So 100, 80, 60, 40 and 20 milliamperes. This is 20, so this is 10. 12, 14, 16, 18 milliamperes of current I could see here. The total resistance is 565 ohms and the total current is 18 milliamperes. Now I am going to measure the currents flowing through R1, R2 and R3 individually. Now I am going to measure the current in R1. For measuring the current in R1, I have to break the circuit at this point and I have to just allow the ammeter to measure the current flowing only through R1. Let me do it. See, I have not touched these two resistances, but this resistance I just moved this end to here 2 points before, and the ammeter connection also has gone here, so that from the ammeter I would see the current flowing in R1. It's reading 10 milliamperes because this is 20, right? So this is 10 milliamperes current for R1. Now we are measuring the current flowing through R2 resistance. So I broke R2 from the junction. I broke the circuit at that point and I kept R2 at a different point, and ammeter is connected here. Now the current is like a kind of 4.5 milliamperes. 2, 4 and little away from 4.5 milliamperes. Now the current flowing through R3, I moved this end 1 point away and ammeter connection is here. Now the ammeter reads 3 milliampere current. Now we are done with the series and parallel circuit. We have measured the voltages, currents and the resistances. You are going to do the calculation for all other columns of the table, and thanks for watching.